Someone turn off the front lights, please.
Front lights.
I don't care who it is. If you just stare at people, usually that generates someone to do it. All right. So taking a look at problem number 1 and 2, they both are ones that have fractions in it. So you could go and solve it. Honestly, the best way to maybe go through some of those might be to clear the denominator. So that first problem you might want to think about being this. Okay? Yes, we have just a numeric value, but if I were to clear the fraction, what would I have to do to everything? Times it by 4, yeah, because 2 and 4 both go into 4. Now some of you might look at this and say, well, what about 8? 8 would also work. It's just it gives you something more to reduce at the end. Okay? And 4 is the same thing as 4 on one side. Now I get 4x. What does this become? 4 over 2, which is 2. What does this become? 3. So now we don't have a fraction. It makes it a little bit easier. Subtract 2 from each side. And then what do I do this last step? Divide by 4. X equals 1/4. Now some of you might have chosen to do it where you subtracted 1/2. You got a common denominator, subtract the fractions. Guess what? Your answer should be identical. It's just, I'm trying to show you there's sometimes a different way to go to a problem. There's a lot of times a really good testing strategy. You know, they've been advertising, ACT and PSAT, and these are all tests that could be coming up for you to take in the future. Does it help you on a standardized test where you have 55 minutes to finish this test, and you go do it? If you get hung up on one problem because you're like, oh my gosh, fractions, well, that doesn't help you. So there's some good techniques that you're learning out of this, and one, clearing denominators is a fantastic technique. Okay, problem number 2, is that c over 4? Is that what it says?
Yeah.
And that's equal to 12?
Yep.
Okay, now this one, in order to solve it, all you have to do is clear the denominator, right? Does that make sense?
Yeah.
So what should I multiply everything by?
4.
And if I multiply everything by 4, or in this case 4 over 1, you've done the same exact operation, and you wind up with this. Huh? Oh, because they would have had justified. They wanted you to justify. So, but I'm not looking for that. I mean, this is from the people who generated this test, which was not us. Okay. And then, so looking down, you have solve the equation, determine whether the equation has one solution, no solution, or infinitely many solutions. So 3 through 10, are we looking for a numeric answer?
No.
No, we're looking to find out, is there one answer, infinite answers, or no answer? So infinite answers happen when all the letters subtract out from both sides, and you get like 10 equals 10. That's infinite. If no solution would be where all the letters subtract out, and you wind up with something totally not true, like 10 equals 16. Okay, so there's definitely some things to think about on those. So if I just go through, looks like problem number 1, I would have divided each side by 5, and there's one solution. Number 2, number 4, I would have subtracted 5, and I get g equals a number, which is one solution. Number 5, when I look at it, if I start combining like terms, and then all of a sudden if you subtract 3p from both sides, 3p minus 3p is 0p. 0p is? 0p is 0, right? So that winds up with 23 equals 23. Is that true or false?
Yes.
That's true. How many solutions then?
Infinite.
Infinite. Okay. Problem number 6, looks like you subtract 7, then divide by 4, and you get y equals some number. So number 6 has one solution. Problem number 5, or excuse me, number 7, what happens with the t's on the right side? Yeah, they cancel out, so I wind up with 3 equals 11.5. That's no solution, yeah.
Well, I'm kind of confused on number 5 because if you subtract 3p, then it is
Yeah, but it becomes out to 23 equals 23, which is true. That makes sense? And that's where the infinite solution. But on the number 7, when the t's cancel out, you get 3 equals 11.5, and that's nonsense, right? Like we didn't find some mystery that 3 is now equal to some other arbitrary value. Number 8, if you look at that, the x's look like they'll work out just nicely. So I would say just by looking at number 8 without going much further, you're going to have one solution. Yeah. Right? Because you get 10x, and it doesn't matter what the numbers are. You wind up with 10x, you're going to divide it by 10. Okay, and then number 9, let's see, I have 10c minus 3c, so I'll have 7c on the left. I'll have 7c on the right. Okay, so our c's are going to cancel out. So let's see if we get the same answer. 5 times 7 is 35. 7 times 5 is 35. Is 35 equal to 35? That's an infinite solution. And then I'll go to number 10 because now we have some fractions. So sometimes, and again, I want to mimic this over and over and over again because I might be trying to direct you to start considering doing problems this way with clearing the denominator. Plus 1/2 b equals 15. Is that plus 2b?
Yeah.
All right. So I know my b's kind of look like 6's. Can you guys decipher them okay? This is my 6. My b has a straight line. All right. So if I were to approach this problem, I would probably say let's multiply everything by 2 or 2 over 1. Everyone feel comfortable with that?
Yeah.
So this cancels this. That's 3b. That's plus 12. Thank you. And that's plus b. 1b is b, right?
Okay.
And that's 30 and 2b. Okay, so I have 3b plus b. That's 4b plus 12 equals 30b, or 30 plus 2b. Now, just looking at this, can you realize there's going to be one answer right now?
Yeah.
Why can you say that? Why can you go ahead?
Because there's a b and you're going to subtract 2 numbers.
Yeah, so I have a 4b on one side and 2b on the other side. Is there any way if I subtract those from each other, I wind up with 0b? No. So you know right now I have one solution. Are we looking for the answer? No. We just want to know, does it have 1 or 2 or 1 or infinite or no solutions? Yeah. Go ahead.
When I added, so I didn't do the denominators, but I added a half.
3 halves and 1/2. That gives you 4 over 2, which is 2b.
Which is
And then you have 2b on the left and a single b on the right. Same thing.
Oh, okay. I see what I did.
I tried to talk you through that quick because I don't want to. You're seeing it that way, and that's great, but a lot of people aren't. Describe the value for c. I'm gonna skip 11 and 12. I don't think those are good good problems for us right now. Okay. And then 13 and 14. So 13, you have the triangle. So all of the inside angles of a triangle, the interior angles of a triangle, have to add up to 180 degrees. Doesn't matter what the triangle looks like, it'll always be true. What does a little square stand for?
90 degrees.
90 degrees. So we have 90 plus 5x plus x equals 180. 90 plus 5x plus x equals 180. Yeah, is that what we wanted?
It's just
Find the value of the variable, then find the angles. So, all right, so doing this, we're going to wind up with that. You agree?
Yeah.
Subtract 90 from both sides, and then divide each side by 6. 15?
Yeah.
Okay. So here's the thing. We have solved the variable. The problem's not done yet, though. What do they want you to find? Yeah, the angles. Okay, remember, this is one of the angles, and this is the other one, right? So one of the angles is x equals 15. The other one is 5 times 15, which is 75. So I have angles of 75 degrees and 15 degrees. How would you know if you're right? Well, if you go 90 plus 75 plus 15, that equals 180. And that's pretty cool. Joe?
so in the answers we write 75 and 15.
75, 15, and well, x equals 15, so that's the variable. And then one of the angles happens to be that as well, so 15. So 15, 15, 75. Is there 3 spots for the answer?
It's just
Oh, okay. And then number 14, there was one similar to this on the quiz, and some of you were having a tough time with this. I have 5b, 4b, 4b, 5b. Okay? That's some sort of order for the problem, and the interior angles, the inside angles of a 4-sided object have to be 360 degrees. So when I add this up, what's 5b plus 5b? 10b, good. 10b plus another 8b is
18B.
18b. And that's equal to 360. Divide each side by 18. Does it come out to 20?
Yeah.
Okay, cool. So our variable is 20. Then each one of these angles, this angle would be 100. This would be 100. Well, how did I get those?
And 80.
because you multiplied 5 times 20.
Yeah, 5 times 20. And then this is 80 because 4 times the 20 and 4 times the 20. So 100 plus 100 plus 80 plus 80 have to add up to 360 degrees. If it doesn't, that does not, we would have made a small error in this problem. $15 looks pretty good. Let's go to 16. And again, this is just review. I'm not trying to, just wanted you to see some of this. 16, we have 1/2 6x plus 4 equals, is that right? 5 times 2x minus 8. Okay. So 2 ways I could think about this problem. I could go and multiply both sides by 2/1, and that clears our denominator. Agree?
Yeah.
Okay, which sounds good, but if I were to distribute half over the parentheses, do I get a fraction? No, because half of 6x is 3x, half of 4 is 2, and then 10x minus 40. So sometimes the clearing of the denominator might not be the first route. So you have to use a little logical thinking when you're looking at the problem. Okay, if you look at it saying, oh, if this distributes over, I'm going to wind up with all these fractions anyhow. Then that would be, hey, let's get rid of the stuff. Yeah.
So can you just like do the 2/1 just so we have
So
we just multiply the 5 by the 2, or do we do the things inside the parentheses too?
So you do it like that, just the singleton term, and then you distribute this over. So 6x plus 4 equals 20x minus 80. And these two problems here will give us an identical answer, okay, if we work it out. Is that all right? And I'm not going to go through and work it out, but I'm just, that'll give you an identical answer, which is great. I'm just trying to review with you guys. Okay. Let's see. 19. Let's go to number 18. A couple of you guys struggled with the absolute values. Again, we're only going to create this on one side. So is that b minus 12 equals 15? All right. First off, it's an absolute value, so how many answers should we be thinking about getting? 2. Everyone feel okay with that?
Yeah.
Okay, so what we're going to do is, if you recall, this is the distance away from 0, and I have to do that twice because it can happen in both directions. So remember, you have to modify the sign on the simpler of the sides. Is really the basic of what you're doing. So this will give me b equals 27 and b equals -3. And there's my 2 answers. Okay? So, both of the answers. You only put one down, you're going to get a point off, or some of the problems off. I don't know how much I'd make it. Probably 3 points. The number 19. Can I go off this?
Yeah.
19. We have the absolute value of 2r plus 5 equals what? 3r. Okay. So again, absolute value. How many answers should we be thinking about? 2. Okay. So I have 2r plus 5 equal to 3r. That sounds good. And then what's the other problem?
2r plus 5 equals -3r.
Yeah, there we go. feel comfortable with that? So I'm gonna subtract 2r. So 5 equals r. And this one, was that negative 5r? Is that right? So what's r equal to on this one? 5 over negative 5, which is? There you go.
I somehow got 1 for the other one, the positive one. So I subtracted 5 and then did something and I got 1.
Oh, it seems like you just try and start moving the r over. You should have gotten the same answer. You just made a little error in one step, but we'll get there. Number 20, we're not going to worry about. Okay. And I think, what time are we out of here? 8? Is that right? Okay. I think I have enough time to hit 20 and 22, or 21, 22. You all right with that? So I have 5x plus y equals 2. And then the other one, just to write down, 2x plus 5y equals what? 3y plus 8, thank you. All right, and we're supposed to solve for y on both of those, correct? So we want y to be isolated on both of those. So the first one is pretty straightforward. What do I need to do both sides? Subtract 5x. Hang on, I'm not done, everybody. Just because your friend thinks it's time to pack up doesn't mean that you'd be taken away from your education. 22, how should I approach it? There's a lot of places I could start it, I think.
Subtract 3y.
I like the subtract 3y. Subtract 2x, I like that as well. I think they're both going to get the same. You know, I'll tell you what. I'm going to do this. I'm going to go this. I'm going to go minus 2x. And then I'm going to go minus 3y. So watch this. That's gone, right? What do I have here? 2y equals, what do I have here?
Nothing.
Yeah, those cancel. What do I have here?
8x or 8 plus 2x.
8 plus negative 2x, or 8 minus 2x, right? Have I solved for y yet? What do I do? Y equals 4 minus x. Okay, so that is your practice so far. Here is a take-home test. Okay? This is going to look very similar to the test that you're going to take. Now, if it's a take-home test, things that I would consider. Is it going to help you mathematically if you found your best friend who got it all done and you just plagiarized their work and said, here, look, I did so well on it? Is that really going to help you out? No. It's a humble grade. You're right. But in the long run, you didn't actually practice it. You plagiarized from somebody, meaning you took their work as your own, which is not the best way to do it. So I would strongly suggest, if you know people, everyone's going to get this same test who's in CP Algebra 1. So if your friends are in CP Algebra 1, I'd say, why don't you go through and try and do it? And then if you have some friends that do it, say, hey, let's compare answers. And you know what? You come back Monday going, hey, my buddy Jimmy got 3 on this one and 7 on this one, and I don't agree. So can you help me out? Heck yeah, let's do it. Sound good?
Yeah.
All right, this is coming out your way. Huh? So everyone got one?